Well, welcome back everybody. In this video, we're going to be taking a look at our next DMVPN topic where we're going to be adding in crypto, which is the whole purpose of leveraging DMVPN in the first place. Even though you technically don't need crypto to do a lot of the capabilities, it's still the thing you're going to need if you're going to run it over internet like we are simulating here in our labs. So because of the fact that we have our hub, iOS 22, as has a VRF pointing towards ISP1, we're going to have to do some unique crypto on iOS 22, and I'll walk you through that configuration. And then on the other routers, we're going to go and set up the spokes with just a pretty standard configuration for phase 1 and phase 2, and then apply a tunnel profile to the tunnel so that we can actually encrypt the data. But what I want to do is I want to walk you guys through what is actually going to be happening here in case you're not familiar with how crypto works with DMVPN. Because for those of you that have been in the industry or pretty new to the industry, crypto maps are a very common design, which is basically just a construct or a glue, if you will, for a couple of other things like the proxy ACL to match on interesting traffic. You set the peer in the crypto map, and then you set the transform set, which actually is what encrypts the data. And that works. It does its job, but it's very there's absolutely no it's just not, it's just old. I mean, there's plenty of things that are detractors from it, but we want to focus on things that we can leverage from it that are better than that. So you can still take the same construct. You can take your phase 1 policy, and you can take your phase 2 transform set, and you can use that with what they call a profile. Now the profile doesn't rely on the crypto map. So the crypto map is out at this point. Actually, let me do this. The crypto map is out at this point. We're using the profile completely. The profile is going to be a crypto profile, so it's an IPsec profile. Let me all of a sudden it's an IPsec. Whenever I change something, it takes a couple seconds for the computer to catch up to it. But anyway, it is a profile, and then the profile calls the transform set, and then the profile, because we're going to have this cloud, right? And then all of these nodes will connect to this cloud. And what you'll do is you'll apply the profile to the tunnel. So the tunnel profile will get applied, and then any traffic that goes over the tunnel will be encrypted. Any traffic that does not go over the tunnel won't be encrypted, which is the nice aspect of how it works and all that type of stuff. So that's basically what ends up happening here. So we still need to create an ISACANT profile. We still need to specify those attributes that go inside of there. And then we need to create a crypto transform set to define how we're going to encrypt the data with ESP and all that type of stuff, and go from there. So that's going to be basically how we go about doing that. I'm going to walk you through the config and stuff like that, and we'll go from there. I'm going to go ahead and clear the screen off as well. So I'm going to go ahead and grab the config, and I'm going to start on iOS 22. Okay, so you can ignore the stuff on 33. I'm going to go ahead and just shut that tunnel down for the moment. Interface tunnel 1, I'm going to go ahead and just shut it for the moment. 22, so we're not bothered by a bunch of wait for it. I'm going to wait for the tunnel adjacency to fail, and once it does, we'll be able to move forward. So because we're dealing with the VRF on the hub side, we need to do some specific configuration for VRF aware configuration with crypto. The first thing we need to do is the crypto and the keyring. So we're going to type in keyring, and then we're going to give it a name. We're going to type in DMVPN, then we're going to specify the VRF, and then the name of the VRF. So DMVPN, and hit the enter key. Now underneath here, we're going to type in the RSA pre-shared key The address we're going to give it is going to be all 0, so we don't care who the spoke is. We just want a form appearing with it. And then we're going to specify the key itself is going to be Cisco, something very simple. Now, the reason why we had to specify that right here is because the second half of the portion, so VRF DMVPN, is going to map the pre-shared key to the VRF configuration. So if we look at the tunnel, you'll notice that we have the tunnel VRF DMVPN command sitting here, which is going to allow the pre-shared key to work on behalf of the tunnel, since the tunnel itself is not in a VRF. The next thing we're going to have to do is type in the crypto ISACAMP policy 10. We're going to say the encryption is going to be AES, the hash is going to be SHA-256, the authentication is going to be a pre-shared key, and that the group is going to be 5. We're going to exit out and type in crypto IPsec transform set, and the name of the transform set is going to be ESP_AES, and we're going to specify ESP-AES encryption for the cipher, which is pretty strong, and then we're going to specify that we're going to use ESP SHA-256 HMAC authentication. So this will be the back half. And then the mode we're going to set is going to be transport. And the reason why we're going with transport and not tunnel is we're not using a crypto map. If we're using a crypto map, we want to leverage that because there's no tunnel interface for us to terminate this stuff on. If we are terminating using a GRE tunnel, we're terminating the tunnel on the router. We also want to terminate the encryption on the router and not basically bypass it and allow it to go down to the interface level. So we're going to set mode of transport and get that out of there, or put that in play, and that gets us where we need to be. The next step is going to be the crypto IPsec profile. We're going to name this DMVPN_profile. And underneath here, we're going to say set transform set, and then this transform set right here. There we go. We're going to exit out. I'm going to type in interface tunnel 1, and I'm going to have to do a few things. I'm going to set the IP MTU to be 1400, because what we have to do is we actually have to take the tunnel MTU, because by default MTU is set up to 1500, right? Well, that's 1500 if there's really no overhead. We're going to be adding not a ton of overhead, but we're adding overhead. We're adding a IPsec header. We've already got the GRE header, which is taking up, I think it's 24 bytes of overhead. So now we have to basically take the data portion, and we have to smush it in a little bit. We had to take payload away from the actual data and give that over to the header space. So by taking the MTU from 1400 down, from 1500 down to 1400, we're shrinking the amount of payload that can be actually sent. So if you were to visualize a semi-trailer, you have the semi, which is actually going to the tractor itself that's actually going to pull the trailer, and the trailer. The trailer, the stuff that you load stuff into, is going to be your payload. Well, let's say you get a bigger motor and you end up getting, you've got a day cab, or then you add in a sleeper, and then you add a bunch of other stuff on there. Your tractor gets longer. So think of that as your header space. So you're adding more headers. So if you don't shrink the amount of payload, you're going to end up having your headers too long, and that's going to add in fragmentation, and cryptography and fragmentation don't get along. So it's a lot of issues. It's easier to lower the MTU for the IP packet down a little bit to shrink the amount of data that's able to be sent and increase the header space. So what we're going to go do is type in IP TCP adjust MSS down to 1360. These are just numbers that I am used to typing in when I configure this. I'm going to type in the tunnel key of 1, and I'm going to set the tunnel protection to be IPsec profile, and the profile name is going to be DMVPN profile. Okay, that's going to break DMVPN all around the board for us. So if you are planning on using the tunnel to jump across to your spokes, that ain't going to happen. So what I'm going to go do is I'm going to go over to iOS 25, because that's a working spoke at the moment, and I'm going to configure all the details that I need for this here, and then we're going to be able to go to the other routers and configure them. So I'm going to first start off with the crypto profile. So on 22, I'm going to do show run section crypto. And I'm going to copy as much of it over as I can, because the more I can copy and paste, the more I'm guaranteed that everything is going to be working the way that it needs to. Then a lot of stuff is going to be matching. So I literally can take all of this right here and copy it. If you don't copy it and you decide to try to type it in off the top of your head, you're dramatically increasing your chances of doing something wrong, having your crypto not match, and then the tunnel never comes online. I've had plenty of instances where customers have tried to do it on their own. They don't really have a real strong understanding of how crypto works. Maybe they fat finger something or whatever, and they end up calling to have me fix it. So I've done this myself. I'm talking from experience. I've blown up VPNs before, so I've learned from experience. Once I configure it on one side, I copy and paste as much as I can to the other side. The only thing we're going to have to do is with the ISACAMP key on the spokes isn't going to be VRF aware. So we won't be using a key ring. We'll just be using a straight ISACAMP key. So let's go over to 25, and we're just going to copy and paste this config in, just like this. Now I'm going to type in the crypto ISACAMP, and the key is going to be, in this case here, is going to be Cisco. That's it. Key, and then the address is going to be anything on the internet. Simple as that. So I'm going to do show run, or I'm sorry, I will type in interface tunnel 1. I'll type in the IP MTU is going to be 1400. The IP TCP adjust MSS, so the layer 4 communication, is going to be 1360. The tunnel key is going to be 1, and the tunnel protection will be IPsec profile, DMVPN. So let's grab this right here. So I'm going to grab those lines of config, and now the tunnel is back online. So I'm going to do show run section crypto. And I'm going to grab these lines of config. I'm going to put them on CSR 11. Do that. And then I'm going to go to interface tunnel 1. The IP MTU. IP MTU is going to be 1400. The IP TCP adjust MSS is going to be 1360. The tunnel key is going to be 1. And the tunnel protection will be IPsec profile, and the profile name will be DMVPN profile. Like that. So do show history on that. I'm going to take these few lines of config, and I'm going to put it over here on iOS 33, just so that they're already there. The tunnel is shut down at the moment. Let me go over to 25 and grab these lines of config, because as you saw there was an error when I typed that commands in. It said that the profile was not defined. So we're just going to go deploy this, and then we're going to go back to CSR 11 and grab these few lines of config again, and then go back to 33 and plug in the config just like that. So there we go. So now I'm going to go no shut, and I'm going to go back to 22, and it seems to be working. Let me just double check on 33. Do show IP EIGRP neighbor. So I'm struggling. There's a couple of issues I've had with the iOS 33. So I'm actually gonna do this. I'm gonna copy, run, start, save the config, give that a second or two, and then I'm gonna reload the box to see if I can't fix that issue. But for the moment right now, we're going to focus on the other routers, so 22 and so on and so forth. So if we do a show crypto ISA, we have a lot going on here. As you can see, we have multiple tunnels up and running. If we do a show crypto session, we're going to see a lot going on here and stuff like that going. So we have a lot of that happening. And So we have a lot operationally happening. Show crypto IPsec SA, and we're going to see a lot of data going back and forth. So this is just proving to us that everything we've done so far up to this point with the crypto is working as it's expected to, which is what we're looking for. Now if I go over to, in this case here, let's go to switch 19. We do a show IP route. I should have a bunch of routes in the routing table, which I do. So I should be able to do a trace route to 20.20.20.20. Actually, let me do this. I'm going to switch IP and then 20.20.20.20. The source address is going to be 19.19.19.19. We're going to do numeric display, and we're going to do a trace. And you're going to see that the first path we take is going to go through iOS 22, which means we're going to do a phase 2 tunnel connection. I'm going to rerun those same commands. Target address is 20, the source is 19, yes, and enter all the way through. And now we're going to go directly to 25. So if I go up to CSR 11 and I do a show crypto ISA SA, I should have a tunnel going directly back and forth between CSR 11 and iOS 25, which I do. If I show crypto session, I'm going to have a peering that goes, so I have a dedicated peering that goes to the hub right here, and then I have another one that goes directly to iOS 25. Now what's cool about this is I have a spoke to hub and I have a spoke to spoke IPsec tunnel. So as I go and send traffic back and forth between the nodes and stuff like that, it's going to work all day long. So if we were to jump back over to 19 and I was to ping 20.20.20.20.20 sourcing from loopback 0 and repeat it like 100 times, we're going to see a lot of data go across the wire. So my pings are working. If I go over here to CSR 11 and I do a show IPsec, show crypto IPsec SA and peer, and the peer is going to be 25.0.0.5. Actually, what is my peer? 25, sorry. I'm going to see a lot of data going across the wire. So I see packets being encrypted, I see packets being decrypted, and all that type of stuff. That just shows me that operationally everything that I'm trying to do is working. Let me just go back over to iOS 33 and see if there is... it looks like we're trying to come back online. Let's do a show run interface tunnel 1. Everything looks right. Let's do a show IP EIGRP neighbor. And at the moment, I have not tried to form a peering yet. But that's not that big of a deal. So let's go to 22 and just take a quick peek here. We'll show DMVPN. So one of the problems we're having with iOS 33 is that it's the hub is not detecting the spoke sitting behind a NAT enabled device. So let me go back over here to 24 and see if I can't resolve this issue. So if we do a show IP access list, I see traffic trying to go out to the destination. So I see traffic going out. If I do a show IP NAT translations, I see communication going out. So it is trying to do its job and trying to get out online. What I'm going to do is I'm going to try to resynchronize the NAT, because I've had this working in the past without issue, and now it's not working. So I am going to take the config off of this box. I'm going to turn it off. So I'm going to disable NAT, yes. And if this does not work, I'm going to save the configuration on iOS 24 and I'm going to reload. I'm going to hit the put the config back in. We'll see if it has any effect on it. I'll do a show IP NAT translations, and I should have a UDP connection going for 4500 out, and that should help me form a peering with iOS 22, and that doesn't seem to have any effect. So in this situation here, is a little unique to try to get it up and running. Now, you might ask, would you ever recommend running a DMVPN spoke behind NAT? And I would say no. I would not recommend doing that. I've done it in the past through a firewall, an ASA 5516, I believe is what it was, and we had no problem with it. And but these are software routers; things do go a little wonky every now and again, but it is what it is. So since that's not working, I'm going to go back to here, and I'm going to actually copy, run start, save the config. I'm going to reload 24 and see if that has any effect on it. But I'm not going to make you guys waste your time until that happens. I'm just going to go ahead and reload the device and get that squared off and see if that helps remedy the problem. Because what should happen is that 22 should see traffic come in from here as a NATed device, and it's not seeing this. The few times that I've done this in production, it's you see the NAT coming across. You have no problem seeing that. As a matter of fact, I don't know if I'll be able to go far enough back here with it. Back when I was doing some testing and writing a lot of the labs. Let's see if it'll actually show the output. Yeah, right here. Right here it shows that it was behind NAT. So I know it works 100% of the time. It's just in this particular case, for whatever reason, the NAT configuration is not being detected. So therefore, when that happens, the spoke that's sitting behind the NATed device, the communication that's going back and forth isn't successful. So basically, traffic can get out from 33 through 24 outbound, but the return traffic from 22 through 24 back to 33 does not work for whatever reason. So it never actually comes up and becomes operational. So we're waiting for for 24 to come back online. I'm not going to make you waste your time waiting for that, but that's the issue that we're having is the DMVPN hub is not seeing the NAT flags, if you will, from 24 to indicate that the NAT is happening, and that's the main issue that we're having right now. So I'm going to reload the box, see if it takes that has any effect, and if it does, great. If not, so be it. But in this particular case here, it is what it is. I'm not going to waste too much time, because it's more of a what's the word I'm looking for? It's more of a nice to have it working than it is you really would want to have this operational, because in most cases, if you're running NAT, you're running it over the internet. My goal was to prove to you that you don't need to run crypto with it in order for it to work, which if you check the website, it does work 100% without NAT. In this particular case, it's not working with or without NAT, with crypto, without crypto, but in most cases, you're going to run it with crypto over the internet. So can you run DMVPN over an MPLS? Sure, you can. We'll be taking a look at that in a separate section, but that just goes to prove to you that it does actually work. So with that being said, I see everything back up and running. So 33 is back online. Does it see? Yeah, it still sees it as the NAT entry is not coming through. So it's still not quite right, and I'm not sure why it's not doing it. But at any rate, I'm not too terribly concerned about that. Worst case scenario, I take the config, drop it back onto 24 and get the spoke back up and running, which is probably what I'm going to end up doing. So as a matter of fact, since we're right here and we're not quite at the 30-minute mark, let's just go ahead and do that. Let's do a show run section crypto, we'll abandon the whole spoke behind NAT capability. Because if you want to, if you want to see it working, go ahead and check the website, and you'll see the config. And I've proved it in multiple outputs that it does work. I'm not going to waste any more time trying to get it to work in this particular case. So I'm just going to take this config right here and take it over to 24. Show IP NAT translations. It's trying to do it, but for whatever reason it's not having much success. So we have that, and then I'm going to take the config from 33, show run interface tunnel 1, and I'll just basically take this syntax right here, and I'll go to 33, I'll type in no interface tunnel 1, I'll go over to 24, interface tunnel 1, I'll paste this config in like so, and I'll type in no shut to bring it back online. And that should have no problem getting us an EIGRP adjacency up to iOS 22. And well, one thing I'll have to do is remove the NAT syntax. So we won't be able to form a peering, because what you'll end up running into is a it's not going to register right away with it because there's NAT configured on the interface. So let's go back and fix that real quick. So on interface, do show IP interface brief, interface gig 0/2, no IP NAT inside, and then gig 0/0, no IP NAT outside, and that's going to turn off the NAT capability. And as soon as it does, we are going to do show run section NAT and get rid of that main line of configuration, which is the global config. Do something like this. Pull that out. Yes, delete the entries. And then we'll go into interface tunnel 1, do show IP interface brief. We'll type in shutdown to balance the tunnel. And then we'll type in no shut. And do show run interface tunnel 1. Oh, and then the IP NHRP NHS 10.1.1.22, the NBMA address is going to be 122.0.0.22 with multicast, and that'll fix our problem, because right now I actually missed that config earlier. So do show IP EIGRP neighbor, and we have an adjacency with 22, and then 33 show IP EIG or show IP route EIGRP, and we have all of our routes, which is what we would expect. So we've brought it back to a working config, and now we are at the point where we are ready to go. So we can move on to the other variations of DMVPN as we're going along here, and get everything else up and running. So until next time, guys, thanks so much for stopping. Actually, let me do this. Let me go and do a trace route to 20.20.20.20, sourcing from loopback 0 numerically. So we take a path through the hub, and then we go directly to the spoke. 24 should have show crypto ISA, and we have a peering directly to CSR or iOS 25. We do a show crypto session. We see that we have a direct connection to them, and we are in good shape. Beyond that, ladies and gentlemen, that's pretty much all we need to worry about. On 22, if we do a show DMVPN, we have an active connection up and running, and that's pretty much all we really need to have. So Until next time, guys, thanks so much for stopping by, and we'll catch you guys in the next video.